Determine the sum to infinity of the following infinite series. Let us begin. We're going to name this series. We're going to name this as sum up to infinity. That represents sum to infinite number of terms. So here we have the first term, that's 1. This is added to the second term, which is 5 over 3. Then we have the third term given by 12 over 3 squared. Added to 22 over 3 cube. And then we have 35 over 3 raised to the power of 4, and we have the rest of the terms. Let's name this as number 1. Now this particular series, this infinite series, is not an arithmetic series because it does not have any fixed common difference. Also, it's not a geometric series. That's because it does not have any common ratio, and if it is neither an arithmetic series or a geometric series, the third possibility is that it could be an Arithmetico-Geometric series. That means a series which is composed of two types of sequence. One is an arithmetic sequence and another is a geometric sequence. So for this, what we'll do, we'll consider the first term. From here, we're going to pick up the value 1. Then from the next term, we pick up only the numerator, which is 5. Then we pick up the third term, the numerator of the third term, that's 12. Then we have 22, then we have 35. Now this particular sequence is not in arithmetic progression. It's not forming an arithmetic progression. However, if we consider 1 from the first term, 1 over 3 from the second term, 1 over 3 squared from the third term, 1 over 3 cube from the fourth term, and the remaining terms, these terms are going to be in geometric progression with common ratio given by 1 over 3. Okay, so what we will do, we'll take this common ratio r and we're going to multiply each terms of series 1 with 1 over 3. So we have 1/3 of sum of the infinite terms, that is equals to 1 multiplied to 1/3, that's 1 over 3. Added to 5 over 3 times 1 over 3 gives us 5 over 3 squared. Added to 12 over 3 squared times 1 over 3, that gives us 12 over 3 cube. And then we have 22 over 3 raised to the power of 4, and we have the remaining terms. So let's name this as number 2. Now what we'll do, we will subtract 2 from 1. So subtracting 2 from 1, we get 2/3 of sum of the infinite terms. This will be equals to 1 added to 5 over 3 minus 1 over 3, so that gives us 4 over 3. Added to 12 over 3 squared minus 5 over 3 squared, that's 7 over 3 squared. Added to 22 over 3 cube minus 12 over 3 cube, so that's going to give us 10 over 3 cube. Added to 35 over 3 raised to the power of 4 minus 22 over 3 raised to the power of 4, so that's 13 divided by 3 raised to the power of 4. And we have the rest of the terms. Now here, if we consider from the second term onwards to the infinite number of terms, this particular sum, this is going to be a in Arithmetico-Geometric series. So let's verify that. So for this series, if we consider the numerator of the first term, that's 4. From the second term, we consider the numerator, that's 7. Then we have 10, 13. Clearly, these are going to be in arithmetic progression. And then we have the denominator, 1 over 3, 1 over 3 squared, 1 over 3 cube. So these are going to be in geometric progression. So that means we can say that this series is an Arithmetico-Geometric series. Now to find out the sum of the Arithmetico-Geometric series, well, what we'll do, we'll have to multiply each of the terms of the Arithmetico-Geometric series with the common ratio 1 over 3. Now what we'll do, we're going to multiply throughout with 1 over 3. So that means we get 2 over 9 multiplied to sum up to infinity. This will be equals to, now 1 over 3 multiplied to the first term gives us 1 over 3. Added to 4 over 3 multiplied to 1 over 3 gives us 4 over 3 squared. This will get added to 7 over 3 cube plus 10 over 3 raised to the power of 4, and we have the rest of the terms. Let's name this as number 3, and then we have number 4. So what we'll do, we'll do 3 minus 4. 4 over 9 times the sum of the infinite terms. This will be equals to 1 added to, so 4 over 3 minus 1 over 3, that's 3 over 3. Added to 7 over 3 squared minus 4 over 3 squared, so that's 3 over 3 squared. Added to 3 over 3 cube, added to 3 over 3 raised to the power of 4, and we have the rest of the terms. Now we have 4 over 9 times sum of the infinite terms equals to 1 added to, now this is a infinite geometric series. The first term a, that's 3 over 3, which is simply 1. And the common ratio r, that's 1 over 3. We know the sum to infinite terms of an infinite geometric series, that's given by a over 1 minus r, which means we have 1 over 1 minus 1 third. Simplifying this, we are going to get 3 over 2. Let's substitute here. So we get 1 plus 3 over 2. So 4 over 9 s infinity will be equals to 5 over 2. So sum of the infinite term, that comes out to be equal to 9 times 5, that's 45, divided by 4 times 2, that's 8. So that means we have 45 over 8 as the sum of the given infinite series.